Hi everyone, it's Rohan this side, and I welcome you all to the new video by Lemniscates Academy, where I'll be giving you a step-by-step solution for AS level physics paper 2 that was asked in October-November 2024 session, and this is the variant 2 for the same. Now just note that guys, if this kind of videos are helping you, the step-by-step solutions, how I break down the questions and explain the solutions for the same, if it is really helping you, please go ahead and consider to give likes to my videos, and also don't forget to subscribe because in the upcoming few months, I'll be uploading more content about the AS level physics and mathematics. And also please don't forget to share it with your friends or anyone whom you think this kind of videos might be very much useful. So yes, with these things being said, don't forget to like, subscribe, and share this video with your friends. Now, let's get started. So, let's get started with the first question. And in part A, we are asked to state what is meant by a vector quantity, a pretty straightforward question. So, a vector quantity is a quantity in which we are having two different things. First of all, the magnitude, which tells you about the amount of that quantity, as well as the direction. And for example, I have mentioned about velocity and the force. Obviously, there are a lot more other vector quantities that we have in physics. But let me help you explain only one so that you get an idea about the vector quantity. What is velocity? So let's say if there is an object which is trying to move in the left direction with 5 meter per second. So over here, the magnitude is called as 5. What is the amount with which the object is moving? That is 5 meter per second. And then if it's moving towards the left, according to the convention that we use, let's say negative 5. So velocity of negative 5 will automatically indicate that there is an object that is moving at 5 meter per second in the left direction. This is only if I'm talking about a horizontal plane and not including a vertical plane or a two dimensions. So that is how you define a vector quantity. You should have a magnitude as well as the direction. If I was moving towards the right hand side and not the left hand side, then I'll write normal 5 without the negative sign, that is positive 5, which indicates because I'm talking about velocity, not speed. If I was just talking about the speed, it is 5 meter per second. I'm not really talking about if it's moving in the left side or the right side because speed is a scalar quantity. So I hope you got the idea. It is a straightforward question that we are having, only one marker. So yeah, that was about the vector quantity. Now part B. A sphere falls vertically through a liquid that has a density of 830 kilogram per meter cube. Now, there is a sphere that is having a radius of r and a constant velocity v. Now, because this sphere is falling down in this particular liquid at a constant velocity, it means that the acceleration will be equal to 0. There is no acceleration because it is moving at a constant velocity. I hope you are aware about that idea that acceleration is the rate of change of velocity. In a given time, what is the change in your velocity? That is your acceleration. So because your delta v is 0, so your acceleration will be 0. That is how I got this idea that for the constant velocity, we know that the acceleration is 0. And now the equation of the drag force acting on the sphere is given by this equation where your d is the drag force as given over here. 6 pi is a constant, r is the radius of that sphere, n is the property of the liquid which is unknown, and v is the velocity, the constant velocity with which your radius is, or I should say sphere, is falling down in that liquid. Now we are asked to determine the SI base units of n. And to get this done, we first need to rearrange this equation and make our n the subject of formula. And for that, I'll change my color and I'll say that my n is equal to d over 6 pi rv. So to determine the SI base units of n, I'll need to convert all of the right hand side quantities into its SI base units format. So drag is a force, and because it's a force which is defined by mass into acceleration, the SI base unit of mass is kg, and for the acceleration it is meter per second square. And then 6 pi is in the denominator. Because 6 pi is a constant, it does not have any kind of SI base units. But for the radius, we know that it is measured in meters. And for the velocity, it is meter per second square. I mean, sorry, meter per second. Now, if I just have to solve this, kg is only one time appearing in the whole equation in the numerator part. So I'm just left with kg for the kg part. If I talk about the meter part, so this meter gets cut with this meter. I'm just left with 1 meter in the denominator, and therefore m to the power of minus 1. And then for the seconds, I am having s power of minus 2 divided by s power of minus 1, which can be written as s power of minus 2 minus of minus 1. This is the law of indices. And then because this minus minus becomes positive, minus 2 plus 1 is minus 1. So I'm just left with second to the power of minus 1. So the base SI units for the N, that is the property of the liquid, we are having kilograms per meter per second. And that will become our final answer for this particular question, kg per meter per second. Now, state an equation showing the relationship between the magnitudes of weight, drag force, and the upthrust force acting on the sphere. So because the object is moving down the liquid, the drag force is going to be experienced on the top part. And upthrust force, obviously because it is upthrust, it is going to act in the upward direction. And weight, because Earth is trying to pull the object down, weight is always going to act vertically downwards. We know that. So according to this equation, if I need to find the net force acting on the body, so my F net will be coming out to be the positive force is d plus u, and the negative force, because it's acting in the opposite direction, the downward direction, so that will become minus w. So my F net is given by this, and according to the Newton's second law, we know that F net is equal to 0. Why 0? Because F net is equal to ma, and because acceleration is 0, my F net is 0. And because my F net is 0, I can say that my W is equal to d plus u. I know that this is equal to 0, so I'm just shifting W on the other side. So that is how I get W is equal to d plus u. And that becomes my answer for part 2. W is equals to, my weight is equal to my drag plus upthrust, that is acting on the sphere. Now moving on to the third part, it is given that the volume of the sphere is 4.6 centimeter cube. Just note that the final value that we have to give for the weight is in SI units, newtons. So I'll need to convert my volume from centimeter cube to a meter cube first. Okay. Then we are also having a drag force of 0.30 newtons. We have to calculate the weight of the sphere. So if I just scroll up, we don't really need to use this formula because the value of d is already given to us. And then because d is given to us and we can find the upthrust because we are having the density of 830, we have the gravity of 9.81, and the volume is also given to us. And therefore I can find my upthrust, and therefore I'll be having my W is equal to U plus D, which is written in the format of upthrust is given by rho gV, density, gravity, volume, and the drag value is already given to us. I don't need to write the formula that is given to me over here. But that is the equation that I'm going to use to find the value of my weight. So what is the value of rho? The value of rho was 830, that is given to us in the starting of the question. Then the value of the gravity is 9.81. And then the volume. I first need to convert this centimeter cube to a meter cube. I know that to convert my centimeter into meter, I need to do 10 to the power of negative 2. That is the conversion from centimeter to meter. Now because centimeter is cubed, this is going to be cubed and it is going to become 10 to the power of negative 6. And therefore I'll need to multiply this with the volume of 4.6 into 10 to the power of negative 6. So that is my upthrust force plus the drag force, which is given to me in the question, 0.32 newtons. And then if I use my calculator to get the answer, 830 into 9.81 into 4.6 10 power of negative 6, And if I add this with 0.32, I am getting the value of 0.35745 dot 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 newtons. And then with respect to two significant figures or two decimal places, it's going to be 0.36 newtons. So that is the final answer for part 3. So now let's talk about second question. In the first part, we are asked to define the momentum. So momentum, as mentioned over here, is the product of mass and the velocity of the object. And the way that I have defined is simply I've written the equation, and based on the equation, I've just mentioned about what is m and what is v, where m is the mass of the object and v is the velocity of that object. Simple as that. Now for part B, a child stands on the scooter on the horizontal ground, and the combined mass of the child and the scooter is 16. So basically the scenario is something like this. You are having a horizontal ground and a combined object. Let's represent that with a circle. That is a combination of scooter plus the child. It is of 16 kgs. The initial speed, the child starts from the rest, and therefore the value of that initial speed becomes 0. Pushes once the ground with her foot, which causes her to accelerate. So it is the child is applying a force because of which she starts to accelerate. Initially, she was at rest, and then the push lasts for 1.1 seconds, because of which she is able to accelerate in the forward direction. It's starting to move with the velocity of 0.6. So initially it was at rest at t is equal to 0. My u was 0. Then at t is equals to 1.1, my v is equal to 0.6. That is the kind of information that is given to us. Now based on this, determine the average resultant force acting horizontally on the child and the scooter during the push. So based on this information, I can say that because we are asked to find the resultant force, which is nothing but the rate of change of momentum. And for the rate of change of momentum, I know that the formula is mv minus mu. If I take m in the common, I'm having mv minus u, which if you open it becomes final momentum minus the initial momentum by the change in time, which is 1.1 seconds. So I'll just write over here for now delta t. So this will be equal to, the mass is given to us as 16 kgs. The final velocity you're going to achieve after 1.1 second is 0.6. And then the initial was obviously 0 because it's starting from the rest. And the time it took from going from 0 to 0.6 is 1.1 seconds. So that is going to give me the average force, which is the rate of change of momentum. And if I implement all of this into my CAIE, my answer is coming out to be 8.727 dot 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 newtons. So based on this, I can state that my answer comes out to be 8.7 newtons. So I'll just mention it over here. Now, moving on towards the part C. So initially, the child and the scooter was traveling on the horizontal ground. Now, after a while, child in B travels down the slope at a constant angle of the horizontal. So basically, there is some kind of a angle this slope is making with the horizontal ground, and it's a constant angle, so it's a constant slope that we are having. Let's just call it as theta for now, as shown in figure 2.1. Now, at point A, she is already having the speed of 0.6 meter per second. She has a constant acceleration of 0.85 meter per second, parallel to the slope. So the acceleration that is acting parallel to the slope, so in this direction, she is having the acceleration of 0.85. And the velocity at which she is moving at point A is 0.6 meter per second. It's not at rest, but having some speed of 0.6. And then after 3.7 seconds, so it took 3.7 seconds to go from A to B. Now at B, obviously because she is accelerating, her speed is going to be more than 0.6 at this point. What is that speed? You can find it with the help of V is equal to U plus AT, if at all we are asked to find that. But for now, let's just go back and calculate the distance traveled by the child along the slope from A to B. So it is not asking for the velocity at B, but the value of the distance that it traveled from A to B. So the things that we are having over here is the initial value of the velocity. We have the acceleration in that direction. We are having the time taken for that. So I can simply use S is equal to ut plus half at square. Because I'm having uat, I can find my S using S is equal to ut plus half at square. And you might be wondering that why are we using this equation? So we are using this equation because it is valid for any straight line motion. So because this is happening in a straight line, and how do I know if it's a straight line or not? Because this angle is constant. So it must be moving in a continuously straight line, straight motion. And in that motion, I am having the value of acceleration, the velocity, and also the time it took to go from A to B. So I can surely go ahead and use this equation. And therefore, if I come over here and mention what kind of formula we are going to use, it is going to be ut plus half at square. And then my u value is 0.6, my time value is 3.7, half the value of A is 0.85 meter per second square and 3.7 square. Based on this, the value of S that I will get in my calc, if I plug all these things into it, 0.6 into 3.7 plus half into 0.85 into 3.7 square comes out to be 8.0382 meters. So based on this, I can state that the value of X comes out to be 8 meters. So that is the value of X that we have got over here. And now if we talk about part D, it is given that at point B, the child in the previous part applies the brake with a constant force. And that constant force is going to result in constant velocity for that particular child in the scooter between the journey B to C. The point C is 80 meters away from point B, and that is why this distance is marked for us in the diagram. Now, the work done by the braking force, which is the resistive force for this particular motion, between the B to C is coming out to be 250 joules. So 250 joules is nothing but your work done because of the resistive force. That is braking force in this case. Now we have to determine the magnitude of that braking force. So I know that the equation of the work done is given by the force into the direction in which the force is being applied. So my F over here is the braking force, which I can also call it as a resistive force for this particular motion. So in this case, Fr is something that I need to find because the distance is going to be the 18. My work done is going to become 250 joules. And yeah, that's it. I just need to find my Fr. And because it's a resistive force, I can mention it with the negative sign. And because the resistive force is acting in this direction, with respect to that, my equation will become minus minus and minus minus will get cancelled out. And therefore, I can simply state that my work done because of the resistive force is 250 joules is equivalent to the braking force into the distance of 18 meters. And therefore, my Fr comes out to be, if I do 250 by 18, it is going to be coming out to be 13.888 newtons. So the least significant figure is 2, and therefore I'll write this answer as 14 newtons over here. Now for the second part, on figure 2.3, which is this figure, sketch the variation of the kinetic energy of the child and the scooter which with distance travel from point A to point C. Numerical values of kinetic energy are not required. No problem. So in between 0 to x, there was no work done because of the resistive force or the braking force. There was only two things, kinetic energy and the potential energy. So because the height was decreasing, my kinetic energy is increasing, right? So I know that my PE is getting converted to KE. My height is decreasing and all of that is converting to my kinetic energy. So I can say that my mgh is being converted to half mv square. And I can directly see that there is a relationship that my kinetic energy is proportional to h. So because it is directly proportional, because m and g are constant for an object, I can simply say that it's a straight line. So now we are going to say that in between 0 to x, that is between A to B, right? From A, we are starting our journey as mentioned in the question, travel from point A to C. So at point O, the distance is 0, and then till B, the distance is x. So in between A to B, my kinetic energy is linearly going to increase till this. So let's something like this. But then there is a catch over here. When the child in the scooter was at point A, the value of the velocity was not 0. And because the value of the velocity was not 0, my kinetic energy cannot be 0. And therefore, I'll need to start something above 0, which is 0.6 was the value of the speed. So half into m into 0.6 square is obviously not 0. So let's something over here we are starting. And then linearly, we are increasing the kinetic energy as the distance is moving. And now, based on this, I am also having the final part that is in between x to x plus 18, that is in between B to C. That is my point A, that is my point B, and that is my point C. So in between B to C, I know that there is a constant velocity over here. Constant velocity. Obviously, that means acceleration is equal to 0. But obviously, because the constant velocity is there, the change in the kinetic energy is not going to be there. Because velocity is constant, my kinetic energy will also be a constant. And therefore, there will be a straight line from B to C. So that is how I'm going to answer the second part of this question D in question 2. And I hope that is giving you some kind of a sense of how I have achieved first this part where the key was directly proportional to the distance moved, and then in between x to x plus 18, that is in between B to C, because there was a constant velocity, my kinetic energy remained constant. Even though my h is increasing, there is no change on the right hand side. And therefore, my final answer in between B to C will be a horizontal line. Now for question 3, in part A, the variation of the stress with strain for a particular metal P is given in this diagram. And we can see that strain is given in the percentage and the stress is given with respect to 10 to the power of 7 value. Now point E is the elastic limit for the metal P. And using that given figure, we have to determine the Young's modulus. We know that Young's modulus is nothing but stress over strain. And we can basically find the gradient of this line. Let's say with respect to this point, I guess after this it is starting to curve. So over here till here, we are having a straight line. Yes. So I can say that the gradient over here will be change in y, which is 21, 22, 23, 24. So that is 24 into 10 power of 7 pascals. And in change in x, it is 1%. So I can say that my Young's modulus is going to become change in stress over change in strain, which is 24 into 10 to the power of 7 divided by 1%. Which if I write in the calci, 24 into 10 to the power of 7 by 1%, it comes out to be 2.4 into 10 to the power of 10 pascals. And therefore my Young's modulus is going to become 2.4 into 10 to the power of 10. Now in part 2, it is given that on the line in figure 3.1, draw a cross showing the limit of proportionality and label this as point Q. So clearly I told you that after this point we can see that the line is bending. So the limit of proportionality is only true till this point, and therefore I just mark it with a cross and label it with point Q. So that is where we are going to have the limit of proportionality for the metal P. Now in part B it is given that state the conditions necessary for an object to be in equilibrium. So there are two conditions that we must know. So for an object to be in equilibrium, the net force and the net moment, both of them should be equal to 0. And the same things have been written over here. And in part C, a wire is used to hold a uniform shelf AB horizontally in the equilibrium. So because it's in equilibrium, the net force in the xy directions will be 0 and the net moment about a point will also be equal to 0. And I can just state that the force in the wire can be given as a tension. So I just mark is a T over here. And if I just have to mark it vertically, I can say that over here it will be T sine 50. And if I had to label it in the x direction, it have been T cos 50. But I'll not show it in the x direction because it's not required for this question. Now the wire is connected to a midpoint of shelf. So it is the midpoint, which is half of 0.65. So it is half of 0.65, which is 0.325. Okay, 0.65 is this full thing. So with respect to A, we can say that it is 0.325. Also with respect to B, it is 0.325. And then this angle is basically 50 degrees to the horizontal. The shelf is attached to a wall by a hinge at point A. The length of AB is given to us as 0.65 and his weight is 33 newtons. So I'll just do one thing. I'll say that I'll erase this part and mention that my weight over here is actually 33 newtons and this distance is 0.325 meters. This looks better. Now a cup that is weighing 1.5 newtons, so I'll just mark that, rests on the shelf with the center of gravity at a horizontal distance of 0.12 from point B. Now by taking the moments about point A, determine the tension in the wire. Very simple question. If you are aware about the moment concept, the anti-clockwise and the clockwise moment are going to be equal about point A, then this question is just a piece of a cake. I'll just need to figure out this distance. So I know that this distance from the center till the B is 0.325. So from the 0.325, if I take away 0.12, I am left with 0.205. So this distance is 0.205 meters. Now taking moments about point A, with all the forces acting in this object or on this object is pretty visible. We are having a T, we are having this weight and the weight of the cup. This is the weight of the shelf, this is the weight of the cup. So both of these force with respect to A are trying to get this shelf moving in this clockwise direction, whereas this tension in the vertical direction is trying to make it move in the anti-clockwise direction. So I'm going to say that the moments about point A with respect to anti-clockwise is given as the force into the perpendicular distance with respect to the pivot is 0.325, and for the clockwise it is 33 into that distance plus 1.5 into 0.325 plus 0.25. So to write this in equations, it's going to be something like this. So clockwise moment are going to be equal to 33 into 0.325 plus 1.5 into 0.325 plus 0.205, because that's the distance from that weight that is perpendicular to point A, adding both of these values. And for the anti-clockwise moment, we just have T sine 50 into 0.325. So T sine 50 is equal to, into 0.325. And now, because the shelf is in equilibrium, I can say that my clockwise moment is equal to anti-clockwise moment, which equals to, if I do 33 into 0.325 plus 1.5 into 0.325 plus 0.205, it comes out to be 11.52. So 11.52 is equal to, what is sine 50 into 0.325? It is 0. Not 3 but 248964440 into T. And therefore, if I have to make T the subject of formula, it is going to become 11.52 divided by answer, which comes out to be 46.271 newtons. And therefore, the final answer for this part comes out to be 46 newtons, which is correct. Now, moving on towards the second part, the stress in the wire is 1.5 into 10 to the power of 7 pascals. So at a particular point, we know that the stress in the wire is this. We now have to determine the radius of the wire. So we know that stress is given by force over area. And based on this, what we can do is the force that is applied because of the wire, that the tension that we have got is 46 newtons, and the area, because we are talking about the wire, we can say that the area is pi r square, and therefore my answer will become 46 divided by pi r square. That is my force divided by area, and which is equal to 1.5 into 10 power of 7 stress. So based on this, the better way of writing this is this: 1.5 into 10 power of 7 is equal to 46 by pi r square. And therefore, if I make r the subject, the answer will come out to be 46 divided by pi into 1.5 into 10 power of 7. And whatever is the answer, I'll need to take the square root of that, and it comes out to be 9.9 into 10 power of 4. So 9.88 into 10 power of minus 4 meters. And based on this, I can state that my final answer is going to be 9.9 into 10 power of minus 4. So if the stress in the wire is 1.5 into 10 power of 7, the radius will be coming out to be 9.9 into 10 power of minus 4 meters. Now, more items are added onto the shelf. Apart from the cup that we were having on the shelf, we are now adding some more items. That is going to double the stress in the wire. So the stress, if it was 1.5 to 10 power of 7, now it's going to double that value of the stress. The wire is made from the same metal P, and because of that we can say that the Young's modulus is same. Now using figure 3.1, we have to explain whether the wire will behave plastically or elastically as the stress doubles. So what we have to say over here is, because the value of the stress is doubling, okay, because the value of the stress is doubling, we just need to make sure is it below the elastic limit or not. And for that, I'm just going to move on towards to my graph. And what was the value of the stress? 1.5 into 2 is obviously 3. So 3 into 10 power of 7. So with respect to 3 into 10 power of 7 is way below the elasticity limit. And because of that, because it is below the elasticity limit or elastic limit, we can say that wire is going to behave elastically. So I hope this is, yeah, 10 power of 7, right? This is with respect to 10 power of 7. And double the stress is going to make the value as 3 into 10 power of 7. And based on that, we can say that as the new stress is within the elastic limit, wire behaves elastically. And that will be my final answer for part 3. And now for question 4, part A, it is given that with the reference to the direction of transfer of energy, we have to compare the oscillations of the transverse and the longitudinal progressive waves. So for the transverse wave, we know that the oscillations are perpendicular to the direction of the transfer of energy. As opposed to that, in the longitudinal wave, we have compression and the rarefaction. So over here, the oscillations are in the direction that is parallel to the direction of the transfer of energy. So based on this, I have written these statements. You can go ahead and customize it in your own way. And then for part B, a pipe is open at one end and closed at other with a piston. So we know that it's open over here and closed over here, and that is why we are having a node and an antinodes over here. Now the piston can slide freely, and currently it is at a distance of 4.5 into 10 power of minus 2 meters from the open end. A loudspeaker is positioned near the open end and emits a sound wave of a single constant frequency. Based on that, a stationary wave is formed in the pipe as illustrated over here. And we can clearly see that over here we are having a node and an antinode with no node in between. We know that between two nodes, the distance is lambda by 2. So over here, it is half of that, right? It is half of that. That will be lambda by 4. So this distance given to us is lambda by 4 meters, which is equal to 4.5 to 10 power of minus 2 meters. So on the figure 4.1, first of all, draw a letter A at the position of the antinode. So that is something that we have already done over here. Then in the second part, the speed of the sound in the air is given to us as 340 meter per second. Now we have to determine the frequency of the sound wave that is emitted over here. So we know that V is equals to F into lambda. V is the sound, F is the frequency, lambda is the wavelength. So based on this, if we have to find the frequency, we need to know what is velocity. It is 340 divided by lambda. So lambda can be found out with the help of this equation, that lambda by 4 comes out to be equal to 4.5 into 10 power of minus 2. So my lambda will be simply equal to 4 into 4.5 into 10 power of minus 2 meters. So based on this, I can say that it is equal to 340 by 4 into 4.5 into 10 power of minus 2. And then if I use my CAIE and substitute these values in my CAIE, let's see what am I going to get. 340 divided by 4 into 4.5 into 10 power of minus 2. It comes out to be 188.888, so approximately 1900 hertz. So that is how we are done with the part 2. Moving on towards part 3, the piston is moved to the left. So now this piston is moved to the left. The frequency of the sound wave emitted by the loudspeaker is then changed, so that stationary wave is formed with same number of antinodes. So basically, the idea is the same, that we should get the same kind of a stationary wave with the same number of antinodes. So we are going to get the same stationary wave like what we have got over here, but the length is going to be increased. So what is going to happen over here is, uh, my lambda by 4 will now have more length, more than what was given to me over here. So based on that, state and explain the change that is made to the frequency to get this done. So over here I can say that my lambda is proportional to L. So if my L is increased, my lambda is increased. And then according to this formula, I can see that my F and lambda is inversely proportional to each other. So if my lambda is increased, my frequency is going to decrease. And therefore I can state this thing over here as my lambda or wavelength is proportional to the length of the pipe. Hence, as the length increased, wavelength will increase. As wavelength and frequency are inversely proportional, or I can simply write this as wavelength is inversely proportional to frequency. Just a second, I got some kind of an update. Never mind. Frequency should decrease. So if you decrease the frequency of the loudspeaker and then the pipe is taken to the left side, then we are going to get this same kind of a diagram. Let's say piston is somewhere over here, so this kind of thing can be achieved. And that is how we solve the question on the waves. Now for question 5 part A, we are asked to define the electric potential difference, which is the amount of work done per unit charge. Then we are given a power supply, and based on that we are also given 3 resistors and an X component, which is a heater, as we can see from the circuit diagram. And the power supply has an electromotive force of 230 volts and negligible internal resistance. The current in the power supplies is 7 amperes. Identify the component X, so it is going to be our heater. Then show that the potential difference across the resistor 0.86 ohms is going to be 6 volts. So V is equals to IR. So for example, if we are having a voltmeter over here, if we have to have a reading over there, so the current it's getting is 7, the resistance is 0.86. So as we know that V is equals to IR, so for that component, it is going to become 7 into 0.86. It should come out to be 6 volts. 7 into 0.86, if I do, it's coming 6.02, so it's approximately equal to 6 volts. 6.02 can be considered as 6 volts. Now we have to determine the current in I1. So to determine the current over here, I can use my Kirchhoff first law, where the current entering the junction, so let's say I input is equal to the current leaving the junction, that is I1 plus I2. So I can mention that my I input is equal to my outputs, that is I1 plus I2. So to find my I1, if I am able to find my I2, then I1 can be easily found. The reason I'm going for I2 is because I know that this is a parallel connection. And for the parallel connection, the potential difference remains the same. That is, if you measure your voltage over here, it will come out as 230 as over here, because they are the same branch. And therefore, I can say that the potential difference across the 170 ohm resistance is 230. So what will be the current? So I can state that my I2 is V by R, that is going to be 230 by 170. I hope the values I've taken is correct. 230 by 170, yes. So 230 over 170 comes out to be 1.3529 something. Whatever it is, I'll not convert it into decimals. I just say that my I1 is equals to the II, which is 7. Input current was 7 minus I2. And then if I just solve this in my calci, it comes out to be 5.647. So 5.6 amperes will be my answer. 5.647 amperes. Now based on this, calculate the PD across the component X. So now we have to find the voltage over here. So now we know that this is in series. If I just talk about the first loop, so what's going to happen over here is there will be some potential difference of 6 that is considered out of 230. There will be some kind of a potential difference over here also, and then I just have to take away 230 from this total, and that will be the remaining one over here. So because the current is constant, I can do that thing, right? In the same Series circuit, the current remains the same. In parallel, the voltage remains the same. The PD remains the same. And that is why in the previous question, if you see, I have considered to be 230 over here across 170 because it is a parallel connection. Over here in the series, throughout this part, this whole loop, after this junction, this will start I1. So over here also it will be I1. So according to this, what I can do is, first of all, let's find what is the value of the voltmeter reading over here. So I1 comes out to be 5.647. So I'm going to use that to calculate my V is equals to IR. So V across 2.4 ohm resistance. This comes out to be 5.647 into 2.4. So that is equal to 13.55. So if this is 13.55 and across we had 230 and this is 6. So my PD across component X will be equal to 230 minus my 13.55 minus 6. Why minus 6? Because 6 was also considered over here. Okay, this is 13.55. And based on this, if I check my answer, 230 minus 13.55 minus 6, it comes out to be approximately 210 volt. 210.45. That is what I'm getting. So that is approximately 210 volts. So yeah, over here it was 6, over here it is 13.55, and over here it is approximately 210 volts. Now, calculate the power dissipated in the component X. So for this, I know that the current is going to be 5.647. V is this. So P is equal to IV is what I can use to get the power over here. So P is equals to IV. The current is 5.647. V is 210. So it comes out to be 1185.87 watts. That is approximately 1200 watts. Now the purpose of the circuit is to provide power to component X. Determine the percentage efficiency of the circuit. So the designing of the circuit was mainly to uh, provide the power to your heater. Now the power that you are getting over here is 1200 watts, and if we check with respect to your 230 volts and 7, what was the input power that it was getting. So efficiency will be calculated as output power by input power into 100. So based on that, I can write that efficiency of power comes out to be output power by input power into 100. That is the percentage efficiency. So output was 1200 and the input is what? 230 into 7 into 100. And then if I do this 1200 by 230 into 7 into 100, it comes out to be 74.5%, which is approximately 75%. So you are having the efficiency of the circuit as 75%. Now, I just mentioned over here that this was 230 voltage. Okay. Now, the resistor of the resistance 170 ohm is removed. Where is 170? Where is 170? Okay. So we are breaking this particular loop. So we are just having the top loop. Now, leaving an open circuit in the lower, okay, so the lower branch is open now. There is no change in the resistance of the component X. So whatever was the resistance in the component X previously without removing 170 and after removing it, it's same. State whether the current in the power supply increases, decreases or remains the same. So Let me read the question again. The current in the power supply increases, decreases, or remains the same. So for that, to find this current, we need to know the net resistance first of all. So the net resistance before removing the X and after removing the X, what will be the impact on that resistance? Based on that, we can comment on 7. So if you are someone who is very new to the electronic circuits, what you can do is you can assume that the resistance for X is some value. Okay. And by using that value, you can find out the net resistance. And you're going to see that if you're having that 170 component and if you're not having that 170 component, if you remove the 170 component, the overall resistance of the circuit will increase. Okay, I can show you the demonstration by, let's say we are considering the value of X as 1, for example. So if you do the calculations of the resistance with respect to these two branches, so 1 by 2.4 plus 1 is 3.4. So 1 by 3.4 plus 1 by 170 comes out to be 0.3. And inverse of 0.3 is 3.333. So the net resistance of this branch will be 3.333. So if you add 3.333 to 0.86, it comes out to be 4.193. Oops, yeah, 4.193. It was with 170. And now if I remove the 170, I'll be having 0.86 plus 2.4 plus 1, that is 4.26. That is after. This is before remove, and this is after remove or removal. So because the value of the resistance increases, the current from the power supply will decrease. So what you can say over here is, as net resistance will increase, current in power supply will decrease. So that is how you solve this question on electronics. Now for question 6, compare an alpha particle with the positron, that is a beta plus particle, in terms of their masses and the charges. Now positron is an anti-particle for the electron. So the mass of the electron with respect to your helium or the alpha particle is negligible. And therefore the first statement comes to compare the mass of the two particles, that the mass of the alpha particle is much more than that of positron, which is a beta plus particle. Then for the charges, we know that alpha is having nucleon number of 2 and the proton number of 2, nucleon number of 4 and the proton number of 2. And for beta plus, it is 0 and plus 1. So what's going to happen over here is, based on the number of protons, we can say that there will be number of electrons. And therefore, if the proton is 2 for the alpha and 1 for the beta, we can say that the charge on alpha is twice of that we are having on the positron or the beta plus. That is how I've done the comparison of the masses and the charges for the alpha and beta plus particles. Now in part B, nucleus P undergoes an alpha decay. So P goes an alpha decay. So the equation will be something like this. P is having the nuclear number of 216 and proton number of 84. That is going to form Q with alpha decay. So alpha will have 4 2. Nucleus Q then undergoes further decay to form nucleus R. So R is going to be 212 and proton number is 83. Okay, great. Now in the part 1, we have to label a cross to show the proton and the nucleon number of the Q. Okay, so we need to find out the nucleon and the proton number by this equation. So out of 216 nucleons, 4 are for alpha, so the remaining are going to be 212 for Q. Similarly, the proton number, out of 84, if 2 is for alpha, we are left with 82 for Q. So 212 nucleon numbers and 82 proton numbers is where I'm going to have my cross, and that is for my Q. And state the names of the particles emitted as Q decays from R. So my R is having 212 and 83 configuration. So From here to here, it became 83. So it must be a beta decay, beta minus decay. That is minus 1, 0. And if it is a beta minus decay, there must be an anti-electron neutrino that must be emitted as well. That is 0, 0. And now if you notice over here that 83 minus 1 will become 82. And therefore the beta decay is the correct answer, which is an electron. So the names of the particles that we are having over here will be electron and anti-electron neutrino. This is a theoretical question, and I assume that you are aware about the theoretical part of the beta decay. Now, in part C, it is given that before the alpha decay, P is traveling at a constant velocity. So it was traveling with a constant velocity. Then after the decay, Q is coming over here, alpha is going over here. So it's a two-dimensional question that we are having. So Q has a velocity of 1.3 into 10 power of 5 with respect to 68 degrees to the original path of P. And the alpha has a velocity of 150, that is with respect to the theta, to the original path. Now, using the principle of the conservation of the momentum, we have to determine this theta. So, because it's a 2D, and we know that the conservation of the momentum is that initial momentum must equal to your final momentum in a closed system, right? So, in the initial, if I calculate the momentum initially in the x direction, it is going to become m into v. So, v is unknown over here for me. Nucleon number is known, so I can find the mass. So for P it was 216 U. But what will I do if I don't know the value of this velocity? In that case, what I'll do is I'll use the velocity initially in the y direction for P, because in that direction the velocity of the P is 0. So using that concept, I can say that my initial momentum of P in y direction is 0, and then I can have my alphas after momentum and q's after momentum, and then I can equate them together. And I'll show you how is it going to look like to find out the value of theta for us. So initial momentum in y direction, so I'll write for q in y direction is going to be 0. Not q but p in y direction is going to be 0. Now this is initial momentum. Now for the final, we are having the q in the y direction as well and alpha in the y direction as well. So alpha will become momentum for the alpha particle in y after the collision is m into v. So m is 4u, and the velocity in the y component over here, because theta is over here, so this will be your sine component. Similarly over here, because theta is with respect to your path p, over here you are going to have sine component in the y direction. So it is going to be 150 to 10 power of 5 sine of theta. 150 into 10 power of 5 sine of theta. And then momentum of q particle in the y direction is, q was having 212 nucleon number, so the mass will be 212u into, and by the way this will be negative. Why this will be negative? Because it's in the below direction. If we have considered from the convention, upward is positive, so downwards will be negative. Momentum is a vector quantity, so it will be minus 212u into 1.3 into 10 power of 5 sine of 68. If I had to take velocities with respect to x-axis, it will be 1.3 10 power of 5 into cos 68, then 150 into 10 power of 5 into cos theta. But with respect to x, because v is unknown, we are not doing that. I hope that is making sense to you. Now this is after. So according to the conservation of the momentum, the equation that we're going to get over here is 0 is equals to 4u into 150 into 10 power of 5 sine theta minus 212u into 1.3 into 10 power of 5 sine of 68. So based on this, if I go ahead and solve it, it is going to become 4u 150 into 10 power of 5 sine theta is equal to 212u into 1.3 into 10 power of 5 sine 68. So I can clearly see that the terms that are cancelling out are 10 power of 5, 10 power of 5, u and u. So my sine theta will come out to be 212 into 1.3 into sine 68 divided by 4 into 150. So if I do this in my calci, so 212 into 1.3 into sine 68 divided by 4 into 150, it comes out to be negative 0.4. Oh, my calci was in the radians mode. Sorry for that. I'll convert it into degrees and get my answer. So it is positive 0.425, 0.425886 something. And therefore my theta will come out to be sine inverse of this, which is 25.2 degrees. So I can say that it is approximately 25 degrees. Now, after this, calculate the kinetic energy of the alpha particle. So alpha particle is going with this velocity. So half mv square is what I simply need to do. So I can say that my kinetic energy will be equal to half into m. For alpha it is 4u into v square is 150 into 10 power of 5 square. I hope the answer is in joules. Yes. So yes, there is no need to convert anything. And the value of u, you can find it in the top 2 pages or in the calci, depending on what type of calci you are using. You will get the value of c over there also. Sorry, u over there also. So 1.66 10 power of minus 27. Scroll down. 1.66 10 power of minus 27, where you can write that u is equal to 1.66 10 power of minus 27 kgs. So based on this, if I solve this, 0.5 into 4 into 1.66 into 10 power of minus 27 into 150 into 10 power of 5 ka square, the answer that I'm getting is coming out to be, just a second, I'll need to change the mode because my answer is coming to be negligible. So it is coming out to be 1.23 into 10 power of 3. So I can say that A is equals to 1.231 into 10 power of 3 joules. So 1.2 kilojoules or 1.2 into 10 power of 3 joules is what I can write. So that is how you solve the last question of this paper. Alright guys, so that's the end of the video over here. I hope this video was useful for you. And if it is, don't forget to like the video and also share it with your friends. Now I'll see you maybe in some other video where I'll be solving the past paper solutions or I'll be giving you some kind of tips and tricks. And for this kind of videos to be updated, just make sure you are pressing the bell icon and also subscribing to my channel. And this, I'll see you very soon in some other videos.